This video is going to be on naming aliphatic and cyclic alkanes. So the alkane nomenclature follows the IUPAC guidelines. This is a standard for chemistry all across the world, and this allows us to talk universally about structures and structure-function relationships so we all know what each other is talking about when we describe a structure. So as we saw in the last video, alkanes all end, or they're going to have a prefix and they're going to end in A-N-E. That's how we know we're looking at an alkane. This prefix here is going to specify how long our parent chain is. Now each prefix denotes a specific number of carbons. All I'm asking for this course is that we know up to 10. So for 1, it's going to be meth. 2 is going to be F. 3 is going to be prop. 4 is but, B-U-T. 5 is pent. 6 is hex. 7 is hept. 8 is oct. 9 is non. And 10 is dec. So for instance, if I'm looking at a carbon-based hydrocarbon chain that looks like CH3, CH2, CH2, CH3, I would simply count the carbons in this chain. In this case, we have 1, 2, 3, 4. I would look at my prefixes. I see that prefix for 4 is but, and I would name this chain but, and then ane. So we would call this 4-carbon chain butane. Now, when we're talking about chemical structures, it's often difficult or tedious to write out structures like I had just written with CH3, CH2, CH2. So we have simplifications for writing and drawing structures that are going to be very useful as we move along in organic chemistry. So let's look at this carbon chain here. So we have CH3, CH2, CH3. So if we look, we have 1, 2, 3. We have a 3-carbon chain, so this would be called propane. Prop is the prefix for 3. If we were to draw this in a more structural drawing, we might say we have 3 carbons in a chain connected by single sigma bonds. We have 2 hydrogens attached to the middle carbon, and then we have 3 hydrogens attached to the terminal carbons. Now, this is a step further. This shows us where the bonds are rather than just having it in a line structure, in a linear structure. This can show us where the bonds actually lie. But even this is still a little bit tedious. So when we're drawing structures, often in organic chemistry, we draw what's called skeletal structures. And skeletal structures are going to omit some of the bonds. In particular, it's going to omits CH bonds. So we don't have to draw in any hydrogens. In fact, we're only drawing, we're really only drawing substituents that are not carbon, and we're not drawing hydrogen. So every vertices are carbons, and we're going to omit CH bonds. So what that means is I'm going to have 1, 2, 3 points that are going to be represented by carbons, and I'm not going to draw any of these hydrogens that are around here. So I'm going to have a single point connected to another point. That's going to be my middle carbon, and I'm going to have a third point off to the end. So this structure, if we see this in the context of organic chemistry, we would be able to say, okay, we have 1 CH3. This remember, every carbon has 4 bonds to it, since carbon has 4 valence electrons. So we can assume that there's 3 hydrogens at this point since we've only drawn 1 bond. So we can assume this is a CH3. So this would be a CH3. This would be a CH2, since we have 2 bonds drawn, and this would be a CH3. So we have 3 carbons. So if we just see this structure, we know in the context of organic chemistry that we are looking at propane. If we were to draw a longer structure, say we have CH3, CH2, 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 CH3. What we would do is count the carbon chain. We see we have 1, 2, 3, 4, 5, 6 carbons in the chain. And we would draw a 6-carbon chain zigzagging along until we get to the end. So we have 1, 2, 3, 4, 5, 6. And remember, all of the bonds that are not drawn are drawn to hydrogen. If we had something like a chlorine or an oxygen or a bromine, we would have to draw that in, but we do not draw in hydrogens. And every vertex represents a carbon. So this would be called hexane. It's got a 6-carbon chain, and this is how we would draw the skeletal formula for hexane. So that doesn't leave us with the answer to how we would draw something like this. So say we have CH3, CH, which is also connected to a CH3, CH2, CH2, CH3. So how would we draw something like this instead? And how would we name this? So just to redraw that, we have CH3, CH, CH3, CH2, CH2, CH3. So I would say I have 1, 2, 3, 4, 5. So I have a 5-carbon chain, 1, 2, 3, 4, 5. And then on the second one, I also have a CH3 coming off of it. So I draw a CH3 pointing up. So how would we name this chain? And this brings us to the IUPAC nomenclature of alkanes. So in the first step, in naming alkanes is we name the parent chain. So the parent chain is going to be the longest carbon chain that we can find in a given molecule. In this case, we have a 1, 2, 3, 4, 5 carbon chain. So our parent chain here would be pentane. So our parent chain is going to be pentane. So this is going to be the base for our name. The next step is we're going to number. So the substituents meaning side chains or anything attached to the parent chain are at the lowest position. So what does that mean? If we look at this chain, we see we have two ways we could number this chain. We could number it from left to right, or we could number it from right to left. So if we number from left to right, we go 1, 2, 3, 4, 5. If we number it from right to left, we go 1, 2, 3, 4, 5. What I mean by number it so the substituents have the lowest possible position. So we have one substituent here. This is going to be this CH3 group. If we go from left to right, we see that it sits at the 2 position of our parent chain. However, if we number from right to left, we see that it falls at the 4 position of the parent chain. So we're aiming to have the lowest possible position. So we're going to be naming left to right for this particular chain. So we would number it 1, 2, 3, 4, 5 from left to right. The third step is we name and number the substituents. So substituents, especially in particular alkyl or alkane chains, so this is going to be a CH3, are going to be the prefix of how many carbons plus YL. So in this case, a CH3 group is going to be meth because it's 1 carbon plus YL, so we have methyl. And since it's at the 2 position, we would call this a 2-methyl carbon chain. Finally, we're going to put this all together. We're always going to put the substituents first and then the parent chain. So what we would have left together is going to be 2-methyl pentane. And that would all be one word. So this works for one substituent, but what would we do if we have more than one substituent? So if we have more than one substituent, the naming gets a little bit more complicated. So let's look at another example. In this case, I'm not going to write out the formula, but I'm just going to draw it. So we have 3, 4, 5, 6. And I have a methyl, and I have a methyl. So let's go through the order of how we would name this particular species. So in this case, we see we have a pair chain of 1, 2, 3, 4, 5, 6. So our parent chain is going to be hexane, hex for 6. In deciding which way we would number this, we're going either left to right or right to left. In this case, we see that we want these two methyl substituents to be at the lowest number position, so we would go from left to right. So we go 1, 2, 3, 4, 5, 6. So we have a 2-methyl and a 3-methyl. If we have multiple of the same type of substituent, we can combine them into one name. And we would do this by writing it as such. So we have 2, 3, and then since we have two methyls, we would put the prefix dimethyl. These prefixes would be, so we would, 1 would be no prefix, 2 would be di, 3 would be tri, 4 would be tetra, 5 would be penta, and so on, trailing up to deca for 10. So we have 2, 3 dimethyl, and then we have hexane. So putting this all together, we would have the name 2, 3 dimethyl hexane. So 2, 3 dimethyl hexane would be the name of this compound. Let's do one more complicated example. So let's look at this one. Where we have this, this, and this. So again, we would try to find our parent chain, and we see that it's right here. 1, 2, 3, 4, 5, 6, 7, 8. So our parent chain is going to be octane. We have to decide which way to number it, and I kind of already gave it to you, but we're going to be numbering left to right so that these three substituents are the lowest possible position. So we have 1, 2, 3, 4, 5, 6, 7, 8. And finally, we have to name our substituents. So we have a methyl, and then we have a 2-carbon chain, so this would be called an ethyl. This is going to be our 2-methyl. This is our 3-methyl. And this is our 3-ethyl. So we're going to have a 2,3-dimethyl. And we also have a 3-ethyl. And the question is, which order do we name these? Are we going to put the 2,3-dimethyl, then 3-ethyl, or are we going to put 3-ethyl, then 2,3-dimethyl? When we have to choose between substituents, we put them in alphabetical order based on their prefix. So we have meth with an M and eth with an E. We don't count the di. In this case, that's just a numerical value, so we count the M for methyl. If we're comparing methyl and ethyl, ethyl comes first alphabetically, so we're going to name ethyl first in the chain. So we're going to put this as 3-ethyl, 2,3-dimethyl, octane. Now, if we have non-carbon substituents, we're going to name them in a similar manner. So say we have this example here. So we have 2 bromines on a carbon chain. We're going to start the same way. We look at our carbon chain. We see it's a 4-carbon chain, so this is going to be a butane as our parent chain. We're then going to number so that the substituents are on the lowest possible positions. They are sitting over here, so if we go left to right, we see that they fall at the 2 position, which is ideal, instead of going the other way where they would fall at the 3 position. We're then going to name our substituents. In this case, we have a bromine. Bromine is going to become bromo, just like chlorine would become chloro. Fluorine would become fluoro. Iodine would become iodo. So we're going to be looking at this bromo substituent. We have a 2,2. We have 2 bromines at the 2 position, so we have a 2,2 dibromo. And then we have a butane, so our complete name would be, I'm putting it down here, 2,2 dibromo butane. So that would be how we would name this compound. Now, the final step the final complication in naming alkanes is what if they're not in a chain, but what if they're cyclic? So if we're cyclic alkanes, we're going to still name the parent chain as such, but we're going to put cyclo in front of it. So cyclo plus parent. So that means that if we have a 3-carbon chain, the 3-carbon chain is called propane, and we would simply put cyclo in front of it. If we have a 6-carbon chain, we would put cyclo and then hexane in front of it. So we're just taking the parent chain, naming it as we would name a linear alkane, and then we're putting cyclo in front of it. So let's practice naming a cyclic system. So let's say we have this system here, where we have this on that position and this on that position. So unlike a linear alkane, cyclic alkanes, we can really start numbering anywhere. But remember, we still want to keep the substituents at the lowest possible positions. So if we start, say, at this position, and we number around clockwise, we would have 1, 2, 3, we'd have a 3-methyl, and we'd have a 4-ethyl. So that's not ideal. We're going to want to start at one of these two positions that has a substituent already on it. Which position do we start at? In general, we're going to start at the one that goes first alphabetically. So this one is going to be an ethyl. This one's going to be a methyl. So we would start at the ethyl because it comes first alphabetically. So we start here with 1, 2, 3, 4, 5, 6. Our parent chain would be cyclohexane. And we would have a 3-methyl. So this, a 1-ethyl. And a 2-methyl. So our total name, with the ethyl coming first alphabetically, would be 1-ethyl, 2-methyl, cyclohexane. So that's how you would name this cyclic structure. Now, if the parent chain is the cyclic structure itself, we put it at the end. So cyclohexane comes at the end. However, if the cyclic alkane is a substituent on the ring or on a linear chain, we would name it like we would name any substituent. So it wouldn't be cyclohexane, it would be cyclohexyl. So let's do an example like that. So say we have this chain here. We have that. And we have this. So say we were trying to number this chain here. Now we would count our parent chain is linear. We see that we have a cyclopropane is now cyclopropyl. We have 2 methyl substituents, and we would name it, or we would number it going from right to left in this case. So we would minimize the position that these would fall. So we'd have 1, 2, 3, 4, 5, 6. A 6-membered chain is called a hexane. We have a 2-cyclopropyl this time. It's a substituent, so it gets YL. And then we have a 3,3-di, because there's 2 of them, methyl substituent. How would we name this? We look at methyl and we look at cyclopropyl. Cyclopropyl comes first alphabetically, so we would put that first. So we would name this as 2-cyclopropyl 3,3-dimethyl hexane. Long name, but if I gave that to anyone in the chemistry world, they would know exactly what I'm talking about. Just as a final note, there's a couple substituents that have special names to them. So, ethyl, methyl, cyclopropyl, we know what we're talking about. There's some special groups that have abbreviated names that make it easier for us to talk about them. So for instance, and I'm going to put a squiggle, meaning that's where it's attached. So we have 1, 2, 3. If we see a 3-carbon chain attached to anything, we know that it's going to be a propyl, right? This is sometimes labeled NPR or N-propyl. We can call this N-propyl. If, however, the connectivity is a little bit different, and instead of connecting it like that, we connect it like this. It's still a 1, 2, 3 carbon chain. This is no longer N-propyl, but we call this isopropyl. And this is given the abbreviation IPR. So isopropyl looks like this. I think it kind of looks like a Y. So if you ever see a Y sticking off of something, this would be the rest of your chain over here. You know it's an isopropyl. So that's one thing to look out for. Now there's also ones for the butyls. So if we look at this, we have a chain 1, 2, 3, 4. So we have a 4-carbon chain. As normal, we would call this butyl, sometimes called N-butyl, sometimes abbreviated as NBU or just BU. So we would have N-butyl or butyl. If we start changing things, and we'll talk about this in a later video, say we put this here, so we still have a 1, 2, 3, 4 carbon chain. We're now not at N-butyl, but we're at sec-butyl. So this is sometimes abbreviated SBU. If we move that methyl substituent over one more carbon to here, we're at isobutyl. This is abbreviated IBU. And this is my favorite one. This, I think, looks like a chicken foot. If we do something like this, it's still a 4-carbon substituent. We call this tert-butyl, or sometimes TBU. So just things to look out for, naming conventions that make it a little bit easier so we don't have to have complex names when we're naming linear or cyclic alkanes.